Alright, hello all, hello world. Happy Halloween everyone. I might have been 6 minutes late because I was looking up some PNGs to actually put on my stream because it's Halloween and we gotta be festive around here. So yeah. This is day 80 of studying compilers every day until I land a compiler role. There's nothing spookier than I guess doing instruction selection, so we're gonna do a little bit more of that here today. But yeah, yeah, I guess we will get straight into it. So again, last time we, I think, correctly implemented the linearization traversal order, so that cleans things up a little bit. But now we have to, I guess, we have to do the actual substance of instruction selection now. So I'm gonna need to tile some more trees, I think, is the big thing. Got an 80 on the discrete quiz. Nice. I mean, we take those. It's a hard class, so I think that's pretty solid. Yeah. So let's open up this thing again. Okay. Yeah. So this is the stuff that we did last time. This traverse traces thing. What's I looking for again? MIR to LIR. Okay. So we need to generate some more stuff, I think, here. Specifically with generating what's it called? Where is it? Oh right, the branches. So we need some more branch instructions, I think. And we also need to figure out how we want to, I guess, represent these sorts of condition statements. Condition statements in the IR as well. But that's something I'm a little bit less concerned about currently. Yeah. So let's get this started. So yeah, that will also force us to like mix types as well, which will be a little bit interesting independently. Yeah. Yeah. I don't really want to stream for a long time today. I want to enjoy Halloween like a human being would. So we're gonna try to make this a little bit shorter. X86 cheat sheet. I'm looking at this because I want to see which jump instruction we should do. I think we should do jump non-zero, so J and Z, I think, for all the conditions for now. That will make things a little bit easier. So we can uncomment this one. Actually, we can do this. We also need jump, and then we need compare, I think. Compare or test? What even makes the most sense here? We have the set ones. Ah, here we are. So we can compare, I think. Yeah, we can compare against 0, I think, right? Is that the least awful way to do it? And then, yeah, actually that makes sense to me. I think we could do that. And then we can optimize it later once we add more logic. So yeah, let's do compare. I think comp, at least. This will be the one we care about. Let's just move that up there. Okay. So then, what do these need to look like, at least when we generate them? So we should do the compare against 0. And then I guess we want jump not equals, maybe? Yeah, we want jump equals and we want jump not equals, I think. And that will make things easier. Or, Yeah, we can do jump equals, jump not equals. And that will, I guess that will handle that. I want to abstract this logic out at some point in the future. So I think I will have like a condition to op thing, because I guess, how do we use some of this at least? JE versus JZ. Are they the same? Yes. Okay, interesting. Okay, yeah. So we want J any, I guess, is the one we care about. So we want jump equals and we want jump not equals, I guess, for now. Either that or we could store it in a different way. I kind of like having this be more verbose though, so I think we will keep it as is. Yeah, this seems pretty reasonable. Okay, so let's add basic constructor stuff to this. So we have public, we have public and private. Okay, so I guess the compare, what does this do? I guess we need two operands. So 2 and then 1, I guess. So we want, is S a value or a register, or? Oh, 2 sources, I see, okay. So we want, what do we want this to have? Also, let's uncomment some things down there as well. Jump equals, we want jump, we want comp. And then we want jump not equals. Okay. Okay. I guess we could get rid of this as well, because we're gonna be changing this pile anyways. So then, what else do we want to do? Or what do we even take? We have operand. Right, okay, we could do operand putter, I guess. Yeah, okay, that seems reasonable. So we can do this. And then we want 2 of these. So we want source 1 and then source 2. And then the jump, all the jumps we take, we just take a destination. So that will be, I guess, a label. We can just do labels explicitly here for now, and then that will, we can abstract that away a little bit more later. Yeah, okay, so we can do that. We can paste here, and we can paste here. So then all else we need is the accept, and then the constructor for each of these. For the time being, we'll add more things as we need. eventually we're gonna want to, like, I don't know, be able to print things, but until then I think this will be exhaustive enough. So this is a compare, this takes operand, putter, source 1, operand, source 2. Yeah, okay. This makes sense. And then jump takes a label. Yeah, okay. And then we can, or maybe it'd be easier if we just did one jump instruction and then we just gave it a different thing each time. That might actually be useful because we're also going to need to reuse those for set as well. And just to cut a little bit of the clutter, I think this is going to be helpful. There's also some like, there's some register specific things as well, right? And that will also, that's also something I want to think about at least. Actually, we can kind of collapse a lot of the binary op ones as well, I think. Yeah, and then we can store things with enums, and then that will make things a little bit less verbose, I think. Yeah, I think I do want to condense these down then. Okay, so then we also want like a jump condition, I guess. We could just do like a generic jump, and then we can also like, I guess it doesn't really make sense to distinguish it in any way. Yeah, okay. So we can do like, we can add a enum somewhere. We already have an enum somewhere for something, right? I guess not. Huh, okay, well. Yeah, let's get rid of these then. Yeah, okay. So we want comp, and then we want jump. I guess we want like enum, class, comp type, I guess. Yeah. We can just do this. And this is, yeah, maybe we could also, we should just separate out the unconditional one as well. Because we have conditional moves, we have jumps, we also have conditional set. But we also just have like move and set, I think, right? Just unconditionally? We should have that at least. Or maybe not set. Oh yeah, set wouldn't make sense, but we have like unconditional moves. So I think it makes sense to separate out just like unconditional. Yeah, and these all take labels, so that is reasonable enough. Yeah, so we can copy this. And this is jump comp, or cond, I guess. You can do that, and that'll be verbose enough, I think. But maybe we should put this below, huh? Yeah, okay. Arc conditional jump, I guess. Okay. Can do that. And then we could probably condense some of this as well, to be honest. Or at least some of this stuff later. Yeah, let's move the enum up at least as well. So yes, this is... what do you even do with this? We can do E. Or you can do equal, not equal, neg, non-neg, greater, greater, equal. Yeah, we could just use the word, I guess. This is fine. We can be verbose with it. Yes, we can do equal any. We could. Yeah, we can do this, I guess. Yeah, so let's put this at the top, I think. And then we could also do that for these other instructions, but yeah, I think this is reasonable for now. I think push pop is fine, move is fine. Are these... How many registers are these? Oh, there's still 2 registers, interesting. Okay, well... We could even do like binary and then yeah, we could do like binary. Oh, actually no, we need a size on this, I think. Yeah, because these have size, so that matters a lot there. These also will have size, but we can, I don't know, I'll condense them later. That shouldn't be that bad compared to all the rewriting I've done up to this point. So yeah, so we have jump, we have C jump. Is everything down there fine? Jump, C jump, compare. Okay. Yeah, so then the only other thing this takes is comp. Right, is that what I called it? I think that's what I called it. Or we could do cond, I guess? Yeah, we should rename this. Our condition code actually makes sense. Yeah, I like that. Yeah, okay. This seems fine. Okay. We have condition code then, and then that's in there. Okay, so this exists now. We have instruction visitor. We're gonna need to add that in. We're gonna need to update. Oh, actually no, we don't need to update that here. Okay. But what we do need to do is we need to generate these now. So we want. So jump equals LR instruction jump, and then this takes next block, or we want to get the next block's name. So we want T get successor, or we want what's it called? NIR and get number of T get successor. Oh, this needs to be this needs a toString. I did not surround that properly. Let's change that. Okay, I just cannot. Okay, can I like do parentheses properly? Jesus Christ. So we can toString this. Okay. So we can do that, and then instructions, we want to push back that. Alright, we're gonna move that. Huh? Oh. Wait, whoops. Stood make unique. Forgot to make unique this. So it should be like that. So many so many parentheses. I don't really like this. Oh, actually, I have an idea. I could put the get successor in here. Plus temp variable in if condition. Oh wait, this is a thing. Yeah, we could do that. We could try this. We can do this, and the successor is not next block, and then we can change in this to be successor. That's such a funny thing. Yeah, okay, we can do that. That's really funny. So we can do a thing, and then if that condition is true, then we can use the thing. So this is one instance where we can do that, which is really cool. I've never done that before. Okay, so we can do okay, so we can do this. This is auto. So we can do T successor. So we can do that, and then T successor is next block. And then in here we can Can I use T successor here? Oh, I can. Wait, that's really interesting. Wait, that's so nice. Okay, so then we can auto F successor equals that. Yeah, and that lets us save the temporary variables instead of having it outside the scope, which is just a little bit safer as well. It's a really neat thing that I learned kind of recently. Or at least I remember it existed, but I forgot about until somewhat recently. Yeah. Okay, so inverted con jump. So we want a way to invert, I guess. Good luck, thank you. Maybe we could make a separate cond code. HN cond code C++. Okay, let's take a break from working on filling the stuff in and just like updating this. Take a second to update all this stuff real quick. So the first thing, I think we can move this out into cond code. Yeah. Let's also zoom out one level so I have a little bit more real estate. So we can steal all of this. So we don't need type, so I think we can just do this for now. So then we want a map, I think. Unless we want a function. Yeah, maybe I should just define some of these as functions instead. I guess that'd make the most sense. So I want like condition code invert and then on code. And so we can do that. Yeah, we can do this, I think, right? Or we can call it just invert. That will minimize some of the stuff we need to do. I think we tried to do something similar with like types initially, but it just made a mess. Yeah, because I have this like really stupid unordered map thing. That was a little bit dumb. I should just make that a function, to be honest. Yeah, that might be the play. I really don't like how that looks, but oh well. Okay, so we can do this, and then backend. Let's include LAR, and then let's give it font code. Yeah, so we can get rid of that. Is this a thing? Oh, it doesn't do that. Okay, so enum class is fake, but anyway. So we have invert, this is switch, cc. Yeah, so we can just, you can do like that, I guess. Or wait. We want to do this. Yeah, and then we can steal this. Do that. That formats nicely. Okay. Added unreachable there. Or actually, we should just put it outside of the. Or no, that should be fine, right? Yeah, okay. Alright, so I think that's all we need for the const code stuff. Let's wait to add, actually. I want to make sure this is a stable change. Okay. So the two condition code files. Let's add the new stuff from instruction real quick as well. So backend. LR const code. Maybe we just give it the full name. Oh yeah, I guess that makes sense. Or we could just call it condition. Yeah, I kind of like that actually. Or condition code. I think that's more explicit, so that's better, I guess. And then here we need to fix this real quick. Okay, so that's all fixed up. So we need to update the header, which we just did, and we need to update the stuff in here. So we want comp, and that comes before call. All of this comes before call. So we can put this here. Someone is revving their motors outside. Okay, so we can kind of just paste all this over, I think. Yeah, okay. So we can source 1 gets source 1. And source 2 gets source 2. So you can do that. And then this is just any other visitor. but here we want instruction comp except this one should be jump, and this one I pasted over. Whoops. This should be cjump. Okay. So now we just have 2 more constructors. These should be pretty trivial. If I can remember how to write things properly. Pairs, comp, and then label is label. Okay, that's all implemented. Okay. I think now is a pretty safe time to commit. So this, we add condition codes. So add, what did we add here? We added comp, con branch, or C jump, or jump, and then C jump. Okay. So now we need to actually do something with this, which will all live in MIR to LIR. The header doesn't need to change, but the body does. Okay. So yeah, we don't need to compare for the unconditional branch that we had above. It was, where was it? Store free branch. It was branched, yeah. So this, we just have a jump. We jump to that block. Yeah, so here we want to generate for F successor. Okay, here we might just want to make the temporaries actually instead. Also, I kind of don't like how long this is. Yeah, we can just do this. I think this is not that bad, to be honest. We can do that, and then F successor equals T, get F successor. And then, so we can do this. And this lets us just get them once and call it a day. Okay, so then we can, for this here, this should be so this should be C jump, and this takes in the inverted con jump is just I guess this will always be just a comparison to 0 right now. We can kind of just skip all the logical comparators, right? Or no, those just return 1 or 0, so we can just compare against that. And then we can probably like people away some other stuff, potentially. Yeah, okay. So then, yeah, so this we want to take, I guess, we can just throw like auto. For now, this should be condition code. This should just be equal by default, I think. What's wrong here? Oh, I don't think I need that. Yeah, okay. Okay, the true branch should be the exception always, I think, right? So if the true is the next block, then we want to jump if it's the false. So we want LR, or we want like invert CMP. Yeah. Yes, we want that, and then we want number for or wait. So if the true is the next block, then we want to jump to the false. Yeah, okay. So this is good. So we want to jump to F, so F successor. And then this pushes back C jump. Otherwise we want to always just make this conditional jump. Oh, it's good, Niraj. Good to see you. Happy Halloween. But this time we don't need the invert. We can just give that compare. And this gets true successor. Yeah. So the only thing we don't want is, actually, yeah, we should just like try to default to fall through for false, right? So this should be correct. This is hard to reason about at a glance. So then we can just steal this, I think. All right, let's paste under. I overwrote it. God damn it. Yeah, so this gets false successor. Yeah, so we can push that back. Have you heard of OpenGL before? Yeah, I have. It's like the graphics library, right? I haven't gotten a chance to work with it, but it looks pretty interesting. Yeah, this looks reasonable enough. Yeah, okay, I like this. So let's just work through the logic again real quick. So this top case here, true successor is the next block, and yeah, so true successor is the next block. So if it is true, we want to fall through. So therefore we want the invert to not fall through. So we want to invert the compare and then jump to the false branch, which makes sense. And then we can push that back. Otherwise, so this case here is that the false case is next block. So we just jump if true, which is good. Yeah, okay. So we jump if true. And then if false is not next block, then we also just add an unconditional jump to false. Okay. This looks roughly correct to me then. Yeah, okay. Yeah, okay. So we can do that. And then I think that wraps this up at least. We should probably like write a key at the top here because I'm gonna forget what happens. So next block is true successor. Then we want to jump if false to, or fall through to T successor and reverse con jump to false successor. If this is false successor, we want to fall through to, or we want to con jump, or we want to C jump. Yeah, we can shorten the wording a little bit. this seems fine. Or maybe we could just do this. Or this should be inverse, I guess. Next block is false successor, then that. Next block is neither. C jump to T successor and jump to F successor. Okay. This outlines the logic, I think, reasonably. Yeah, okay. So let's get rid of this. Let's get rid of that. Let's get rid of that. Alright. All this is cleaned up quite nicely. Let's paste that up here maybe. Let's put this here. Alright. Because I'm not going to understand this in a year and a half. Get rid of that space, I think. Or maybe we could add more space. I don't know. I guess this is fine. It's all pedantics. Or me being pedantic, rather. Yeah, okay. I like this. So I think that's pretty solid. And then everything else is gonna be horrible. It's gonna be horrific. Maybe I should like add some more comments here and there actually. Yeah, I think this is fine. This logic I feel like I should write out just because it's not really easy to tell what's happening at a glance. There's just a wall. Yeah, I mean, nothing else is particularly interesting to generate, I think. Start basic block is fine. End function is fine. Where is like the end basic block? Or we have end function. I could also add like a regalloc. I could add like a regalloc filler node as well, and then that will like add the caller saved registers on the places where it matters. Okay, what else do we need in the basic block stuff? There was something else I was thinking about. Do we need to generate the comparer, right? Oh yeah, of course we need to we need to generate the compare. That's what we need to do here. Okay, so we want so we can just like throw this. This is all fine up here. Yeah, so auto compare or what's it called? It's just a conf. Okay, so this is cond. Yeah, okay. That seems more reasonable. Okay, so we can compare is make unique. Alright, we want lir instruction compare. This takes so I guess we want let's just do it in order. We can get something and then we can give it whatever 0 is. Yeah, let's give it 0 as well. So we want t get conned, or we want resolve value. This is t get conned, and then resolve value. What is this called? What type is this again? We want a 0 node, right? Stood. Let's just make 0. Let's just make 0 by hand. So this is stood, make, unique. All right, these are these pointers? This is an instruction. We need this. Why are those putters? Test instruction, you don't need a 0? Oh, nice. Oh, that makes so much sense. Wait. Okay, yeah, good comments, Harold. Thank you. Yeah, I will rewrite it to use that then, actually. That's very nice. Okay, so we should test. Let me just rewrite this for now. I really don't have a Boolean, comparison between two values. I don't really have comparators right now, so I think this is like the least dumb way to do it for now. I guess if I will do comparisons in the future, I guess it wouldn't hurt, huh? I think, I don't know, I'm too lazy to add the test right now, but I will just make a 0. I'll add a to-do for myself, as always. So we want test, conned. Yeah, I didn't even think about that. It took me a second to realize because yeah, okay. It'll be non-zero if we AND it with itself. Unless it's 0, then it'll AND all the zeros and make a 0, I guess. Okay, so let's just make a mess out of this. Okay, wait, so we need to give it operands now. Which type is... yeah, let's... There's also like a operand map thing, right, that I need to make. Oh yeah, operand manager. Yuck. Okay, well, let's figure out how to do this real quick. I think we need like some sort of dependency injection stuff as well. Yeah, and this matters because we're gonna potentially add a 0, so... Or we might just like add... Oh, what am I doing? Are there other instances where we'd be like hard-coding operands? Yes, we'd be hard-coding with like some registers, so we'd need to do it like that at least. Let's do this and then like null putter for now. Right? Yeah, resolve value doesn't exist. So we can just do that for a second. Hopefully that doesn't break anything. First try. Just so I don't forget about it. If I try to end stream without fixing this, y'all's job is to yell at me. Because if these stay null pointers, I am going to forget about it. by the time we get to the next stream. So what we need to do real quick is we need to modify the tree gen visitor. This needs to take a this needs to take one like register. What's it called? Operand manager. Yeah, we can do that, I guess. So that goes at the top there with the other stateful stuff. Okay, so we can do that. We need to add that to this thing. We can just call it OM actually. That's pretty funny. We have NIR and we have like I'm eating something because I'm quite hungry. I shouldn't be hungry because I just ate dinner, but I'm quite hungry. I see that a couple more people have joined the stream. Happy Halloween. I feel like I should be more explicit about that one. So it is in fact Halloween. I don't know, I'm like going insane. It might be just a tired day for me. Okay, so let's update the constructor real quick. Why is there oh, I see. So we take this, and then we take our operand, This takes a ref. Don't need that though. Which new event plugins do you use? These ones. I'm gonna go through these a little bit quickly. But they're all on my dot files if you wanted to steal them for yourself. Where did the constructor go? I just saw it a second ago. I lost it. There it is. Yeah, so we take OM, and then this takes OM is OM. Appreciate the jack-o'-lantern emojis. I love them. How many years have you been coding? I've technically, I guess like the first lines of code I wrote were in like elementary, but I didn't really like write substantive code. I think it took me until like end of my freshman year in college to write like quote unquote real code. So I think that means I've been coding for like what, 2.5 years maybe I'd give it. Anything beyond that is like not really coding, but it's up to you how much you want to interpret that at least. I'm new here. Well, welcome. What's going on here? You're trying to write a compiler for some toy language. I'm writing a compiler from C to x86-64. Can I ask why the visitor pattern is needed here? Is it because of LLVM? Not necessarily because of LLVM, but it's just like a general code maintainability reason. So I don't have to like straight up modify the class each time. The class is like, you can think of the class as not really like a quote unquote like object and more just like a data structure. So in that sense, it doesn't really make sense to like have specialized functions all living there, and it makes more sense to separate them out into visitor just from like a one file, one responsibility sort of standpoint. Does this just work like this? It looks like this works. Okay. we have and we've got visitor. That's huge. Okay, so we have here. Next block should be null pointer. Oh, we need a way to update next block as well. Or do we do that in start basic block? Oh wait, no, we need a start function, end function. Oh, we have set next basic block. Do we ever call that? That's not ideal. So we can do that, basic block. This is next block equals basic block. Okay. I think that implements everything. Start, next, and then resolve value. Everything below there is good. End function is good, start function is good, the result's good, constructor is good. And then I think all of this is good. We need to set the basic block real quick. So this takes, oh, this is annoying. Okay, we need to change this to for each, or not for each, just an iterator for loop. So we want for each basic, so this equals, or iter equals f get basic blocks. Alright, let's do this real quick. So we want basic blocks start, or begin iter not equals basic blocks end. Yeah, we can do that. Redefinition of iter. Oh, whoops. Should be semicolon. Okay. So this needs to be changed. It should be iter equals basic blocks end. If that's the same, then we can do null putter else iter plus 1. Right? Or okay, we're gonna do something a little bit gross here. We're gonna do that, and we're gonna deref it. That should be good, right? Can we just do iter? This is terrible. Oh wait, actually let's just do it the other way. If this is begin, then no, this doesn't work. This doesn't work the way I want it to. Yeah, we should always just go for next then. If it's end, then null pointer is fine. Otherwise, how do we get next? Yeah, get next iterator without incrementing. Stood next, that's a thing? Anyway. Stood next. And then this will take iter, right? And we can do that. Jesus, that's ugly. Let's just deref it instead of using get. Okay, so it doesn't let me do that, so we're gonna need to use. Oh my god, what am I doing here? What a crazy instruction. So if it's the end, then there is no next. So then we can null pointer that. Otherwise, we can get the next, which is so stupid. Right, no, there should be, this can't be end, right? Deref end iter. What happens if I deref the end iter? Oh, Jesus. C++ 1 from iterator last element. So impressive, you seem to know how to do all this after 1.5 to 2 years following crafting interpreters. Ooh, good stuff. Yeah, we love crafting interpreters. Yeah. I guess a lot of this stuff just comes from having spent a lot of hours thinking about this. This should be prefix decremented? Yeah. Yeah, let me know if you have any questions about anything that's happening here, at least. I can do my best to explain some things. Are those plugins? They're all pleasant on my GitHub, yeah. My GitHub's in the description. It should be, my dot file should be one of the start things, so yeah. Okay, so this is iter, or we can deref iter, or, oh wait, no, we need, right, because this is an iter to unique putter. There's views adjacent. Yeah, I think that exists. Ranges and views are honestly crazy stuff. I've been trying to avoid them as much as I can, just because I think they're kind of slow, to be honest, but I could technically do those at least. You're like, holy hell, this is some really mangled code. I really don't like what I've done here. This is kind of inevitable though. Yeah, I guess this could be worse, I guess. Yeah, because we need to set the next block just for those reasons that we've outlined before. Okay, now I can replace this thing. So this will take we want to get register, and this takes t get cond, and then this needs to be a toString, so or auto con, we want like cond value equals what is this called? So we want t get cond, or we want, can I do that? Or no, I need to do that. So, and then this we want a toString. Or wait, no, this is just toString. Yeah, it's this thing. This stupid thing. Alright, no, it's not that, it's not that. Thanks, of course. Again, feel free to ask any questions you have. This was LIR, or no, it was NIR, get number from that. And then we want std to string that. This is some crazy fuck ass train coupling. So let's change this out like this. Or cond name, I guess, or num. We can't do cond because we already have that. I think the con, or let's just give it a temporary real quick. Let's rename this cond code. Maybe treat the last one as a special case. Yeah, that could be something I do actually. I guess it's just gonna be a mess regardless. I think I'll just give it another look another day, and then depending on how I feel, I'll change it to be more sensible. Okay, so this takes cond. So we have that, and then this should do get register. This is get immediate actually. Yeah, this takes 0. This needs another parenthesis. Yeah, we don't need that, right? Yeah, okay, cool. So we have that. So we make the comp and then we push it back, which is what we need. Just at the cost of a little bit of mess here. Can I just, if I do this, will that make this less ugly? Oh yeah, that's way better actually. Yeah, okay, I like this more. Okay, so we have the compare, that gets pushed back, and then we handle all of the jump mess, which is ideal. Okay. So I think that is most of what I was thinking to get done today. How many to-dos do we have? The number has gone down by 1, I think. Yeah. This one I want to do later. I don't want to think about merging trees right now. Tiling trees seems like a mess. But I guess it'll be fine. This one I need to think about. This one I need to think about. This pile I need to think about. This I think we need to think about. These are fine. Yeah, okay. I think that's like all the to-dos I wanted to get done today. Maybe the extra... yeah. You might be right about that, actually. Okay, wait. Yeah, this is terrible. I really don't like this whole clobber mess. Maybe I could also just like, maybe I could get rid of the set next basic block thing and just like add it into start basic block. Next basic block like that instead. Yeah, it feels a little bit less bad than having that duplicative function. Yeah, and then this one we can, I guess that also helps with that case, actually. Yeah, so then we can get rid of this thing. So we have that. So then we have next block equals next BB. Yeah, okay. This seems a little bit less awful at a glance. And then we need to change this thing. Which, oh boy. Yeah, okay. I think the separate, let's see, and then, yeah, let's do auto iter equals, actually we can do an interesting little thing here. We can do iter end equals bb's end, or we can decrement that. That's not what we want, I think. Right? Or I don't like the way this looks though. I guess we could do it like this. It feels kind of awful regardless, to be honest. Let's just undo that. Yeah, okay. Okay, let's just have this as a ternary. Next basic block is this. So yeah, auto basic block equals iter get. Alright, we can do that. And then next block is oh boy. Okay. Yeah, so if it is the last one, then it's a null pointer. Otherwise, it's the next block, I guess. Oh, actually, we could just always get the next one. And then if that is end, then it's another point. Okay, wait. I think we figured it out. Auto next equals stood next of iter. Yeah, okay. So we get the next iter, and then basic block, and then next basic block is next iter. If that is basic blocks end, then we do null putter else next iter get. And then that actually doesn't look that bad. Let's just put that in parentheses so it's a little bit more readable. Or I can do that. I like this a lot more already. Yeah, okay, I like this. Yeah, because if it's end, then it'll be no pointer. That, yeah, okay. This solves the really annoying, like, the ugly prefix decrement, which I think is a sign that something has gone wrong. Okay, so we want basic block and then next basic block. There we go. Jesus Christ. Yeah, okay. Or we could just do like start and then end? I don't know. This is good enough. I think I've stared at this logic for a little bit too long. My brain is turning into like jello. Yeah. I don't know. I don't think there's much else I want to do right now. And it's Halloween, so yeah, I kind of want to enjoy life for a little bit. Is there anything else here? Let's build it real quick. This should be fine. So it is not fine. Why is it not fine? Get basic blocks. How do I read this? Sorry, wait. This is in MR to LR line 13. Oh, this needs to be a ref. Is that everything that matters? Okay, that looks like it fixes it, so that's good. Let's rebuild, just from scratch. Hopefully this is fine. Is that? Okay, I'm just tripping. And then the tests. Nothing breaks, which is good, because that, I guess, we don't have a good way to test any of this yet. So as long as nothing that we had before breaks, I think this is fine. Let's just like, let's do that, and then like test, regression, input, let's do like inst combine. Yeah, okay. Okay. That works. This one we add all branch state, or add trees for branch statements plus all the groundwork that relies on. Okay. Alright, I think that's a good place to call today's stream. I'm gonna go enjoy my Halloween. Thank you all so much for showing up today. Make sure to like the stream if you haven't, and sub to my channel if you enjoy the content. It really helps out with the algorithm, and it gets my content out to more of y'all. While you're down there, make sure to join the Discord. It's the best place to get pinged when I go live, and also chat with the broader community. Everyone is really chill. And yeah, make sure to connect with me on LinkedIn as well, and I guess add me on GitHub to stay up to date with what I'm doing. Yeah, hopefully y'all enjoyed the sorry. Hopefully y'all enjoyed the spooky stuff on the stream today. Yeah, take care y'all. Take it easy and have a wonderful rest of your day wherever you are.